Hello everybody. Let's see in elaborate manner one more requirement elicitation for one more functionality. This functionality which we are going to discuss is rear cross traffic alert. Let's see how OEMs communicate to tier 1 the various requirements, or in other words how exactly requirement elicitation for rear cross traffic alert happens. Now the first and foremost thing is detection performance requirements. What are the various detection parameters that must be included? First is detection range. It must detect vehicles approaching up to 30 meters or 98 feet on either side. This is the primary requirement, and must detect pedestrians and cyclists within 20 meters. Now I hope you understand why there is difference between pedestrians and vehicles, because accident or collision with vehicles can be more catastrophic or more damaging either financially or economically or even physically. Okay, that's the reason it must be able to detect a vehicle well ahead than it can detect pedestrian or cyclist. Next is detection angle. Coverage of at least 150 degrees, 75 to the left and right from the rear of the vehicle. Now understand that these are all just an examples. OEMs may slightly vary these requirements also. OEM to OEM, slight difference or slight deviation may happen. I'm just giving you these examples so that you can understand how requirement elicitation actually happens. How exactly the requirements are given by the OEM to the tier 1. Now, next is speed range of approaching vehicles. Detect vehicles moving between 1 kilometer per hour and 60 kilometer per hour. Okay, so this is the velocity range of the approaching vehicles. Next is false alarm rate. Less than one false alarm per 100 reverse maneuvers in real world conditions. Well, in ideal conditions, actually, there should not be even one false alert. But because of the presence of mechanical and electronic parts, hardware, there are some false and alarm rate. Alert timing and HMI requirements. Warning timing. Next is provide an alert of at least 2.55 seconds before potential collision. Warning types. Let's see the various types of warning types that must be included. First is visual alert, an icon on infotainment screen or instrumentation cluster. So there should be a small blinking or of any kind of any icon which alerts the driver that there is some vehicle approaching in the at a perpendicular direction. Next is audible alert. It may be a beep pattern increasing frequency as threat approaches. Well, I'm sure you have seen in any car, as the while you are reversing a car and as you are approaching an obstacle like a wall or a pillar, the beep frequency slowly increases. It starts with slight slow frequency like beep 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 beep, and as it approaches, it becomes beep 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 beep. Okay, so this is the increasing frequency. Next is haptic feedback. Haptic feedback, again, it is optional. Some OEMs may opt for it, but if at all they are using haptic feedback, the seat vibration frequency, or the frequency of the tightening and loosening of the seat belt, all these things must be included and communicated to the tier 1. Next is escalation logic. Will all the above three warnings be displayed at a time or one after the other? First, there should be a visual blinking. Next, there is an audible blinking, and next, haptic warning. Depending upon the convenience or the requirement of the OEM, these requirements should be communicated to the tier 1. Next is the various ambient and environmental conditions where this functionality should work without any kind of any flaw. Okay, weather resistance must function in rain, snow, and fog with defined performance degradation limits. Lighting conditions must work in low light and direct sunlight conditions. Okay, so this is very important when you are working coming out of the parking lane, whether it is a night time or a daytime. This must work equally flawlessly and equally efficiently. Next is the vehicle speed threshold. Now, because this always comes into picture when the vehicle is in reverse gear, the max reverse gear must be clearly specified, and here the OEM has selected the max reverse gear speed is 10 km per hour or 6 millimeter miles per hour. All right. Next, let's see the sensor and system requirements. Sensor type must use a radar 77 gigahertz or ultrasonic sensors with defined accuracy levels. If using cameras, must have low latency image processing. Okay, what is meant by latency? The time gap of how quickly the sensor reacts. Okay, that is called latency. And now coming to radar 77 gigahertz, I'll explain. I have already explained in the sensor section. Explanation is very clearly given in the sensor section why 77 gigahertz is most prevalent. Next is system latency. The total processing delay should be less than 200 milliseconds so that it gives a real-time operating condition as closely as possible. Okay, real-time operating condition should be as close to the real-time working as possible. All right. Next is redundancy and fail-safe. If primary sensor fails, system must degrade gracefully. Now this word, I'm sure you are habituated by now. What is meant by degrade gracefully? So there should not be any kind of any jerk or any wobbling in the vehicle. It must degrade without causing much of inconvenience to the driver. Maybe it can slightly notify the driver via dashboard warning. Even that falls under the category of degrading gracefully. And of course, the legal compliance requirements, you should meet UN R158 European norms or FMVSS 111 US norms for rear visibility systems. Next is the test scenarios or the test cases. Validation required in OEM defined test cases like parking lots, narrow streets. These are all the various test cases where this should be tested to prove its efficacy. Next is EMC and durability. Must pass ISO 11452, EMC and ISO 16750 for environmental testing. These are the various standards that this particular functionality must pass or must prove itself so that it can be released into the market. Next is integration and functional safety. The vehicle integration must interference must interface with CAN, FlexRay, Ethernet. Now this is common knowledge. Irrespective of the functionality, communication must properly happen, and it must have a proper interface capacity or capacity with either CAN or FlexRay or Ethernet, or it may be even LIN also, depending upon the choice of the OEM. And because this is not exactly critical or fatality causing functionality, SLB should suffice. All right, and it also must comply with ISO SAE 21434 for sensor data integrity. All right, next is cost and packing constraints. Bill of materials, total system must cost below so many dollars per vehicle. Now this is something important because all said and done, this is business. Okay, when a OEM approaches a tier 1, they clearly give the cost constraint, and also they must fit with the OEM defined rear bumper design zones. So the OEM clearly communicates a bumper design. What is the curvature? What is the flatness? What is the parallelism? All these design constraints, mechanical design constraints, are communicated to the OEM so that the sensors which the tier 1 suggests are clearly fitting into the rear bumper. Now, example of OEM specific requirements for luxury vehicles may require high detection test, range of 40 meters and augmented reality overlay in the rear view camera. Okay, if it is a luxury car, well, the OEM may select because they have a higher cost constraint or because they can afford, they can even ask for higher detection range for 40 meters. And for commercial vehicles, it may need trailer compensation logic if RTA must work with towed loads. Okay, in the commercial vehicle, when there is a load on the trailer, then also this should work very efficiently. Now this is a very important requirement of Rcta. Okay, now let me continue in the next video.